In this video, we're going to take a look at the snap fit command inside of Autodesk Inventor. Now, the snap fit command can be utilized to create multiple types of geometry, such as beam and hook type of geometry to grab on to existing features on a mating plastic part, or clipping catch methods, so that if you need to place in a PCB board or something internally, you can clip it into that. Now, when you look at the snap fit command by itself, up here on our plastic part command, and you see the options of cantilever, snap, fit, hook, or cantilever, snap, fit, loop, you might think that these are going to work together. That doesn't always have to be the case. If you were clever enough, you could go ahead and create a snap and loop that hooks together, or they can be mutually exclusive, like I mentioned, such as hooking it into existing geometry or being utilized to place in another plastic part, or can be utilized for placing in an electronic circuit board that needs to hook into your plastic part. So to begin with, we're going to start with a snap fit loop type. So go ahead and select that. And we're going to be placing some snap fit loops on the yellow piece of this plastic. Just to see things better, what I'm going to do is cancel out of here and turn off the visibility of my base. I'll restart the snap fit command. Make sure I choose the snap fit loop. Now for centers, I have an existing sketch in here where I'm going to pick up these geometries. And what you're noticing on these is a bunch of additional arrows. We can click on these arrows to adjust the geometry of each independently. Now currently these are going to the outside of the geometry. I want them coming to the inside. So again, there's another arrow on the inside there. And if you need to keep flipping them, just keep clicking your green arrows. I want these all facing to the inside. So now I'll start adjusting our geometry. We'll go here to the clip tab and we'll start filling in some sizes. Here we'll do 4 millimeters. I also want to point out that if you don't know exactly what the values are, there are some 3D green little grips on here that you can pull on as well. So if I start pulling on this one here, it's going to adjust my geometry. You can see that I adjusted that to 1.36. I actually want this equal to my thickness value, which is currently 1.5. My overall height, I'll reduce that a little bit to 4.5. And the tip, we'll leave that at 1. Over on the catch side, we can adjust our values for our opening. I'll leave these at the 0.5 millimeter, 1.5, and 0.5. I'll choose OK, and I'll create those snap fits. So this is great if I need to have something come in here and snap into this, such as another sourced part that we need for our design. I'm going to turn the visibility of my base back on. And this time work on a cantilever beam. So we'll start the snap fit again. I only had one sketch left that was unconsumed. It also picked up the fact that I had a point command utilized on that line of the sketch as well. Now when I zoom in here, I don't want the snap fit type here for this loop. Instead, I'll choose the cantilever snap fit hook. Notice how the geometry is extending down. That's because my extend option is turned on. Now if I just leave it like that, I won't have any geometry to support it. It'd be a piece of floating geometry. So be very careful on how you select where your starting point is and where you actually want the geometry to generate. Here I'll keep extended on, and this will actually build into the draft wall of my plastic part. You also have the same options here for these little grips, as well as the flipping icons. Next we'll move to the beam tab, and I'm going to adjust this to be a little bit wider, so we'll do 5 there. Notice how it fans out. That's because the top here is at 3. If I made the top 5 as well, it would get rid of that fanning out that you saw there. We reduce the total height of this to the inside of the hook down to 3.5 millimeters and leave the rest of those values alone. Now I'll move on to the hook, and we'll change my angle here from 50 to 45. Now as I do this, I'm going to go to the side here so you can see what's going on. There's my 45 change. Keep this at 2.5, 1 and 1. Notice how this is actually going into the geometry of the top piece, the yellow part. I'm going to choose OK there. I'm also going to mirror this around to the other side. I'll just use my XZ plane as my mirror plane. And now I have a snap fit loop using the hook type on both sides. How does this benefit me? Well, it really doesn't right now. It actually is creating an interference in my geometry. So what I'm going to have to do is create an opening here, allow the snap fit to actually take place and catch on to my yellow geometry. So I basically need to do a little bit of extra work, making it so they actually snap together. But here you can see 2 different distinct reasons to use snap fit. So you can easily create some geometry on the inside for hooking other parts into, or to use for connecting your 2 parts to make sure they stay together.